Hey everybody, my name is Paul Abernathy and welcome back to the series where we're talking about grounding electrode systems. Now, I'm hoping at this point in the game you have at least Googled and found out who we are, what we're about, all the thousands and thousands of students we've helped learn the National Electrical Code, and you've taken the opportunity to do me a favor and check out our website by going to electricalcodeacademy.net. And of course, you can get there at masterthenec.com as well. But all roads take you to our website. Give it a look-see. Browse around a little bit. Look at our forums. Make sure you visit the Sparky Hub. At the top, at our main page, if you scroll to the bottom, you get a lot of quick links to our forums and things like that. So check it out. A lot of good stuff there. But we're all about education. And so at this point, we're at part 3 in a multi-part series, and we're talking about the grounding electrode system. Now, I'm hoping at this stage that you have seen part 1 and part 2, because the way we do this training series, all of this is based on our Fast Tracks Purple program. What is that? Well, if you go to our website, you'll notice that all of our courses are color-coded. It's to help you understand where you need to be depending on where you are in your career. The Fast Track Black program is for exam preparation. It's basically a 30,000-foot view of the code to prepare you to take an exam. But it is also the premier program to teach you the basics of the National Electrical Code, whether you're a project manager, whether you're the owner of a company, and you just want to get better knowledge, or maybe you want the people in your company to all have a better knowledge of the National Electrical Code, a working knowledge, let's put it that way. It reduces errors, reduces people. You know how people on the social media will say things are against code, but they really have no way of knowing because they don't put a code reference? Well, those are the type of people that need that course, and that's the Fast Tracks Black program. That's our base program. Of course, we offer a red program for residential code. It really digs deep into residential wiring code. Then we have the green program for commercial wiring, gets deep into things that you would see electrically when it comes to commercial environments, three-phase and all that type of stuff. And of course, we have an industrial program. That's our blue program. Then we have our yellow program, which is basically Electricity 101, parallel, series, Ohm's law, Watt's law, matter, atoms, all these kind of things. You learn all those little nuances that you really should know as a foundation for understanding electricity and working in this profession. And knowledge is king, and so we want to get as much as we can. But then you have the purple. Now, the purple is by far my most favorite because it deals with grounding and bonding. And I think that every electrician out there, if there's any course that you should most certainly have after you get your license, is to make sure you have an extensive course on grounding and bonding. Article 250 is a complex article, and it intertwines with other articles in the code, so you really need to understand it. So we created the Purple program in the Fast Track series that is dedicated to it. Now, this series right now, we're at part 3, talking about grounding electrode system, and we're specifically talking about the electrodes right now. So this is a multi-part series, but right now, we are focusing on the electrodes. As we move forward, we'll talk about the installation and the requirements for installation. Right now, purely talking about the electrodes itself. So go back and watch part 1 of this series. And all of these are available over on our YouTube channel. That's youtube.com/masterthenec. And part 1 deals with talking about how all electrodes that are present have to be tied together. Then they act as one. It also talked about the metal underground water pipe and what the requirements for that, at least 10 feet in length or more, in contact with the earth, and any broken segment, you'd have to have a jumper on it to make it continuous. We talked about that. We also talked about that electrode is required to be supplemented with another type of electrode, okay? And then it kind of went over how many electrodes we're dealing with. So you have 250.52A1, which is the water pipe, A2, A3, A4, A5, A6, all the way up to A8. And that's what we're covering in this series right now. We're talking about each one of those electrodes. And so that was part 1. Part 2, we covered the in-ground steel. That's like I-beams that are driven in the earth 10 feet or encased in 10 feet of concrete in the earth. That was an electrode, and we talked about that. And then we also ended part 2 talking about concrete encased electrodes. Now remember, we're not talking about the installation, how deep and all this kind of stuff yet. We're talking about the basics of it. What is the electrode? Now, of course, I probably went over and above and gave you some of the installation aspects because I can't help it. But we will tie all these things together as we go through this series. And when we're talking about the grounding electrode system, we're going to be covering quite a bit. So look for these episodes. So make sure you subscribe, bookmark, and you come back and you get notified. So be sure to click that subscribe and ring the bell there so you get notified. All right. So in today's episode, we're moving up to part 3. So we're at 250.52. We're talking about A4 and A5. Now, A4 is ground rings. It's probably one of the less used grounding electrodes out there, but it is very common in data center applications. It's very common in like communication tower applications where they'll put a ground ring around the tower. And sometimes they'll even come off of that with ground rods or whatever, depending on what the engineer specified, how much resistance they're trying to get to earth as low as possible. So it's not that they're not used widely, just not what the normal electrician would usually use, okay? But nevertheless, it is an electrode that we're going to talk about. And then we're going to end today's episode talking about probably the most popular electrode that is added, not ones that are part of construction like the water pipe ground or the concrete encased electrode or in-ground steel, which A1, A2, and A3 that are in 250.52, those are inherent to construction. The electrician doesn't install those usually. That's part of the construction process. But when we start getting at A4, now we're getting into electrodes that the electrician would install to get compliant, okay? So that's what we're looking at today. So we're going to start that journey with ground rings. So let's go on and jump into that and look at ground rings. All right, so 250.52A4. Let's talk a little bit about the ground ring. Remember, we're not going to get into the details of installation. That is a separate video. But again, subscribe because it is coming. I promised you that we'd be doing a lot more videos in 2022, and they're on the docket, and we're going to be hammering out. And they're going to be, whether it's residential, we're going to have some in commercial, we're going to have some in the exam prep realm, and we're going to be talking like grounding and bonding a lot because, again, my favorite topic. Y'all all know I serve on Code Baking Panel 5. I love it. That's my favorite committee. I am so blessed that I'm able to serve on that committee. That is by far my favorite committee of all the different committees that I'm on through NEMA, Kanina, UL. This one is my most favorite, Code Making Panel 5. Why? Because the minds that are on that committee, Christine Porter, Phil Simmons, all of those, just amazing minds. And I love being in the room and interacting with these individuals. Just truly very gifted individuals. Okay, so let's look at 250.52A4, the ground ring. And remember, we're just talking about the electrode in this episode. So the requirements are what? And you can follow along in the code. Hopefully you have your code book. It says a ground ring is required to encircle the building or structure, be in direct contact with the earth, and consist of at least 20 feet of bare copper conductor, not smaller than 2 gauge, 2 AWG. AWG being American wired gauge, okay? So here's our takeaways. If I have a building or structure, if I want to use a ground ring, I have to encircle the entire building. Now remember, this is just the ring. We're not talking about the grounding electrode conductor from that ring back to the service equipment. I am just talking about the ring. Now, it also could be a remote building that is fed from a feeder that has a grounding electrode system there, and you're still going to have the grounding electrode conductor make a connection up to the equipment grounding conductor terminal at that remote distribution panel. That's a totally different subject that we can cover at a different time. So let's just keep our mind focused on the service and establishing the electrode for this service. So from the service, using a grounding electrode conductor, we would go down and make a connection to this ground ring. So it has to be at least 20 feet, it has to be at least 2 gauge, and it has to encircle the entire building, and that 2 gauge, which it can't be, it has to be at least 2 gauge, is in direct contact with the earth, right? All right, so we got that squared away. Now, you'll find that if you go look at 250.66c, which talks about the allowance to size the grounding electroconductor, let's say from the service down to this actual ground ring, it never needs to be larger than what's required of the ground ring. So if it's 2-gauge ground ring and engineer specs that and that's fine, then guess what? Then that grounding electroconductor never needs to be larger than 2. All right. Now, if the engineer wants that ground ring to be larger, and it is very common for an engineer to specify a ground ring to be even larger, like a 1-aught or a 2-aught or 4-aught, depending on what they believe they're trying to get the earth resistance down, okay, then they may require something larger. If they do, obviously, the grounding electroconductor would have to be sized equivalent to whatever the ground ring is, right? And if you go read 250.66c, you can pause the video. It's okay. Go and actually read it. You'll see that's what it says, okay? So the engineer could specify it to be larger. One of the takeaways I do want you to remember, it must encircle. It cannot go halfway and stop when it gets to the 20 feet. Okay. Now, it might only need 20 feet to encircle something small like a tower. But if you were encircling a tower building and you wanted to use a ground ring, then it's going to be much more than 20 feet. And that's okay. It has to be at least 20 feet. You with me? All right. All right. So again, here's just some information letting you know that an engineer may require it to be larger. Okay. And if he does, here again, it's very common for them to want it to be 3-aught or even 4-aught. All right, so if that's the case, the ground rings, if they're larger than 2 are installed, then also it reminds you that be very careful of your terminations. All right, so when you're making these connections, because you want to make sure that the terminals can handle that. All right, so that's it. All right, so that's our ground ring. Now, we're not going to get into the depth. We're not getting into any of that, installation practices of that. We covered most of it. But we haven't really talked about the depth that it needs to be, because that's for a different video where we'll be talking about the individual installation practices of all of these, okay? Which leads me into the second one that we're going to talk about today, and that is rods and pipe electrodes. Now, you're not going to hear me talk about the 25 ohms. I might mention it or something like that, but that's part of the installation practice. We're talking about the electrodes in this episode, okay? So ground rods or pipe electrodes have to be at least 8 feet long. They could be longer than 8 feet, but they got to be at least 8 feet. In fact, some rods used can be as much as 10 feet long. And there are some people that in order to get a low resistance, they will connect rods together and drive them down. They can go deep as 40 and 50 and 60 feet in order to reduce the ohms, okay? But at the end of the day, the code says the ground rod has to be at least 8 feet in length. And I guess I will talk about the ohms. The code tells us that it has to be, for one ground rod or pipe, it has to be 25 ohms or less. Or if it's not, we have to add a supplemental electrode. Now, that could be another ground rod. That could be a ground rod with a pipe electrode. It could be a ground rod with a plate electrode. The point is, back in episode 1 of this series, I talked about having to supplement the water pipe the water pipe electrode. Wow, can get a confusing there, can't it? So in this episode, I'm telling you, you have to supplement a ground rod. You have to supplement a pipe. In fact, you would even have to supplement a plate if it's not 25 ohms or less. Okay? So that 25 ohms rule only applies to rods, pipes, and plates. Now, of course, I'm just talking about rods and pipes here, but I just want you to know that that 25 ohm rule only applies to those type of electrodes. Also, the 6-foot separation between the electrodes, if it's a rod or pipe or rods or plates, that 6-foot separation only applies to rod, pipes, and plates. Okay? Don't know if you knew that or not. Doesn't apply to the UFR, doesn't apply to the in-ground steel, that type of thing. Only rod, pipes, and plates. Okay? Don't worry. We're going to cover that. We're going to get deep into that in this series. So relax right now. Let's just enjoy the fact we're just talking about electrodes. All right, so let's talk about these electrodes. All right, so they have to be at least 8 feet in length. Okay. Now, the electrodes for the pipes or a conduit, they can't be smaller than a trade size 3/4. So we can't use half trade size. It's got to be at least 3/4. Okay. So it can't be smaller than that. And when they're of iron or steel, then they must have an outer surface of galvanization or other metal coating for corrosion protection. And that's up to the manufacturer. But typically what we see is galvanized conduit, and that can be utilized. Okay. And so typically that gets driven down, and then you have the threaded end, and that's where you put the connector on it and you make that connection to it, that type of thing. Also, they have the clamps that will actually clamp to the pipe itself as well. So have different ways that you can make that connection to the pipe. Now with the ground rods can be both listed and unlisted. If they are unlisted and they're stainless steel, copper, or zinc coated steel, then of those types, then guess what? They have to be at least 5/8 of an inch in diameter. Right? And remember, when we're talking diameters, what do we mean? So if you look right here, going around this rod, that is the circumference. From the center out, that is the radius. The diameter is from perimeter across the middle to perimeter. That is the diameter. So when they're unlisted, means they don't have that mark within 12 inches stamped on it by the NERDL, Nationally Recognized Testing Laboratory, but they're at least 5/8 of an inch in diameter, then that's what they have to be, that diameter. Okay. Now, if it's a listed ground rod, okay, so it's been manufactured and they got a listing on it, then those can be less diameter than 5/8 of an inch. So what we don't want you to do is go measuring it and some inspectors say, oh, you can't use this. This is not at least 5/8 of an inch. Well, hopefully they look for the actual marking, usually within 12 inches of the top. And if they, again, it's going to be difficult if they bury it. So, most inspectors realize that we have listed rods, right? So they're not going to give you any grief, I hope. But at the end of the day, yes, a listed ground rod can have a diameter of less than 5/8. An unlisted ground rod, let's say a copper one, has to be at least 5/8 of an inch in diameter, okay? So again, it is very common to have to be at least 8 foot. Now, we're not going to go too deep in this, but the pipe and conduit rules contemplates standard schedule 40 galvanized water pipe or rigid metal conduit, RMC, or intermediate metal conduit. These are the kind of pipes and conduits that we're talking about that are installed, but they are definitely difficult to drive. So most people aren't going to use pipes, and I don't know in your career whether you've probably ever used a pipe. Well, most people will use ground rods, okay? So there you go. All right, so, and if you want to learn the history of the testing from ground rods, and you're in our Fast Tracks program, the purple program, there is an Appendix C. And in Appendix C, it actually shows you the testing and installation and what goes on to test ground rods and how to use a 3-point, 4-point fall of potential, clamp-on meters, all those type of things in order to test the ground rods, right? With that said, that is actually going to be all that we talk about with that today, those 2 electrodes, keeping it short and sweet. But I am going to give you a little something extra. When it comes to ground rods, remember, there's 2 electrodes that are required to be supplemented. The metal underground water pipe has to be supplemented by another type of electrode. And ground rods, pipe, or plates, if they don't meet 25 ohms or less, they have to be supplemented. Now, people have asked, what if it's a temporary pole? It's still a service, but it's temporary. Do I have to follow the rules and establish a grounding electrode system there? Absolutely you do. And if you do ground rods and the one rod isn't 25 ohms or less, you are going to have to supplement it with another electrode. Now, obviously, if you're using ground rods, the easiest thing to do is drive another ground rod. It has to be at least 6 feet away from the other ground rod. Further away is perfectly okay, but it has to be at least 6 feet away. And that is what you're going to have to do, whether it's a permanent installation or even temporary. Again, lightning doesn't know any different. The transient voltages doesn't know any different. And so, again, some people don't like that. They're like, Paul, it's just temporary. There is nothing in the code that says that temporary, because in fact, if you go look at 590 for temporary installations, when it comes to the service, it's going to send you back. And it basically, you have to treat it like a service. And you got to have the grounding electrode system. So there's no way around it. So what do we cover? We covered ground rings, at least 2 gauge, could be larger. The grounding electroconductor to that is supposed to be at least equivalent to whatever the ground ring is, whatever the engineer establishes. But again, it can't be smaller than 2 gauge copper. We talked about the ground rods, 8 foot in length, although you could have 10 foot in length. And we haven't talked about the installation aspect of that, but I need at least 8 foot of a ground rod. And of course, in future episodes, you'll see that I have to have 8 foot in contact with the earth. And if I drive it and I hit rock, then I can go up to 45, and I've hit rock, then I can actually lay it in the trench. So we're going to cover all of that in an upcoming episode. So yeah, we have covered underground water pipe ground electrodes, in-ground steel electrodes, concrete encased electrodes, ground rings, and we covered a rod and pipe electrodes. So what do we got to cover next? Well, we got to cover the other electrodes, okay, like the chemical style electrodes, and we'll see a picture of that. And then we got to get into plates and talk about the plate and the rules for the plate electrode. And then we'll probably deal in the last one, which is a local system like tanks or things like that. A well casing that is not connected, let's say, to the underground water pipe electrode. So again, we'll get into all that. So yeah, we're just getting started in this series. So hopefully you got something out of that. So stay tuned for part 4, and we're going to knock out these other electrodes. And then after we knock out the electrodes, then systematically we'll go in depth in the details of how each one of them are installed. Okay. All right. Till next time, folks, stay safe. God bless, and thanks for joining me. Remember, subscribe, hit that bell to be notified, and we'll catch you next time on another episode here at Electrical Code Academy.